Hi, I'm Dylan Attridge. You've seen me in such fine quality epic chemistry educational videos such as Canuminati, Confirmed, and Illuminati is for Losers, and Half-Life 3, Confirmed. Okay, this lab we are going to look at food coloring. The kind that you can do Easter eggs, you can add it to food and whatnot. And we're going to look at different concentrations of food coloring, and we're going to analyze a couple of things. We're going to look at, one, does it make a difference as far as the concentration of food coloring in solution in terms of the light? That we're going to use a special device called a colorimeter that is going to shine a beam of light through our sample, and we're going to get a transmittance, percent transmittance. So we're going to analyze that. That'll be question number one, which that should be pretty much a no-brainer question. The more food dye particles you have, what would you expect as far as the transmittance of light? The other question that we're going to look at is what kind, if we were to graph the concentration of our food dye compared to our percent light transmittance through our colorimeter device, what kind of a graphical relationship are we seeing? Now, in order to get to that, there's several things that we're going to have to look at. One, we got to figure out a way to dilute our concentration. Now, I'm just using this as an example of a food dye. It's a nice, cute little Easter egg thing. But I need to introduce to you a couple of pieces of equipment. One, this is our volumetric flask. Now, the volumetric flask does come in different sizes. The purpose of the flask is allowing you to make a solution of a certain concentration. You would be adding your solute first into the flask, and then after that you would be adding distilled water up to a certain level in the neck. And I'm going to show you guys what would that look like. So here is a 1,000 milliliter volumetric flask. We're not going to need that for the lab. We have a 100 milliliter volumetric flask, smaller, looks a little more cute, but we're not using that. No, we're going to go ahead and use the 25 milliliter volumetric flask. Now, what you need to look at here is that there is a line, a white line on the neck. You should be able to see it. That's going to be our fill line when we're making the solution. So I'm going to go ahead and I'm going to show you guys how to make a solution using a volumetric flask. That's going to have to be an important part of the lab because you are going to be diluting concentrations of food coloring, okay, before we run the tests. What is that going to look like? Well, first, we have a volumetric flask, and we're going to make sure that it's rinsed out, that there's no dust in there. But the last time I used these, we put the plastic cap and that was it. Okay, so you can go ahead and you can take the squeeze bottle here, and the idea is that we're rinsing it out. Okay, so we're just rinsing it out. I'm just shaking it around just to make sure if there's any dust or other unwanted particles, and then we're just going to go and dump it into the can, into the sink. So now we have something. It's distilled water, so we're good. Now, could we use regular water for this experiment? Yeah, we could, because we're not using a whole lot. We could, but I think we're going to work with distilled water. Now, here I have food coloring. Now, at this point, the concentration of the food coloring, it's really, really tiny, and I may just give it a value to start with so that's easier for us to go and work with it. But the idea is we're diluting. So we're going to take one drop, we're going to put one drop in the flask. Okay. So we have our 1 drop in the flask, and you kind of notice, oh, look, it's got the purple stuff in there. Well, it was around Easter. Now, what we can do, we can use a flask for this, and this is going to be the tricky part. The tricky part is what we don't want to do is overfill beyond the neck, okay, beyond the line that's on the neck of our flask. So I'm going to go ahead, and I'm just going to gently squirt in there, okay. So you guys can use squeeze bottles for this, and if you notice, I'm slowly filling it up, okay? This is how chemists prepare solutions. So you are learning a valid, valuable lab technique. You'd say, okay, do we need to ignore the air bubbles? Well, we want to try to get rid of those air bubbles in there, okay? And you kind of notice it's pretty easy to do so, okay? All right, now we're getting closer to the end here. Now the air bubbles are slowly working their way up. Now, here we are, we're almost at the end, and I really don't want to use the squirt bottle anymore. How come? The reason for that is I could overfill, I could go beyond that white line. And remember, with that, you need the meniscus. Pay attention to the meniscus. Okay, so I'm going to go ahead and, let's see, try to tap out the air bubbles in there. They're all at the top, so that's not so bad. Okay. Now, believe it or not, the concentrations are already very dilute to begin with. We're talking about like times 10 to the minus 6th molar, believe it or not, for these. And I cannot get my hands on the original powder to make the dye with, because then I can sit there and mess around with the molar concentration. So I have to take it as I get it from the store. Okay? Okay. Oh, come on. Get that in there. All right. So I'm going to cheat a little bit. I'm going to go ahead and I'll just slowly add, I know I'm going to, okay. All right. So I would give you guys a dropper and a little beaker so you can slowly add it, and then pay attention to the top. Then, once you got it at the top like this, you're going to take your blue plastic, you're going to cover it like this. Okay? All right. Now we're going to go back. Now that you have it done, you can start inverting it. Okay? The reason why you're inverting it, you want to make absolutely sure that you're spreading out the food dye throughout the entire distilled water. Remember, you're diluting the concentration. I'm going to give you guys the stock solution. I'm going to have to water it down from the original thing because we need to get some kind of a reading, and then we're going to start from there. Okay. Now, at that point, even though I've mixed it up, it's okay if you got all these air bubbles in there. That's fine. We just want to dilute it. Okay? Now, next thing. So our solution is done. Now what do? Well, we need to get our hands on, you're going to have a dropper, and I'm going to have to hang on 1 second. I need to get a dropper for this. Oh, dropper, dropper, wherefore art thou, oh, dropper? The one time in my life I need a dropper, I'm in the lab, and I can't find one. Wow, that really stinks. That's okay, I will get one, never fear, I'll be right back. As we go get the dropper is what we need. Oh, la, la, the dropper's what we need. Hey, with the dropper, with the dropper. Okay, now we can go do something with it. So, I'm back. And no, I wasn't planning on making a singing career. All right, now, I need to introduce you to a couple of more pieces of equipment that we're going to be using. You guys already know the Lab Quest. You know that one already, but there is another piece. And for that, ladies and gentlemen, I'm going to take the camera off its mounting. All right, so here we go. Blair Witch Project, here we go. Camera style of the Blair Witch Project, it's a reference. Okay, so you're already familiar with the LabQuest. Now, I'm going to operate the LabQuest unit, and you may notice that there is something called absorbance. Okay, and it says time-based. It's not going to be time-based. I'm going to go ahead and quickly fix that because I'm going to make that an event with entry. That's what we're going to deal. So I have absorbance. I'm going to hit the go button. Now all that, I'm ready to go with it. That's not the main point. The main point, we're looking at a device called the colorimeter. Now, the idea behind the colorimeter, if you open this up, the secret compartment, you'll notice, hey, there's a square hole in there. You're right. And in there, we're going to be putting in a special tube called a cuvette. We'll get to that in a minute. All right. Now, for the colorimeter, the idea is it's shining a beam of light through the tube, the special tube, and it's going to give us a result. How much light is actually getting through? Okay, because we're going to look at percent transmittance, which I'll demonstrate in a moment. So, here we have different wavelengths of light. So we can check this out at different wavelengths of light and see what's happening with it. How does that affect the results? CAL is the calibration. You're not going to worry about that. I get to worry about that. All right. So now you saw the basic device that we're going to use. I'm going to put this back on the mount. And now we're going to shift back down here. What do we do next? What's our next thing that we're going to do? I'm going to show you guys, got to talk to you guys about the cuvette. Okay, and that's it right here. I'm going to kick this up a little bit more. Okay. Remember, I am a one-man team, and since I'm a one-man team, that does make it a little bit more of a challenge. All right. This is a cuvette. Now, if you look at the four sides, you'll notice two of the sides have ribs on them. That is the sides that you can grasp with your fingers. The smooth side is the side that the light inside our colorimeter is going to go through. We want to keep that as clean as possible. Clean as possible! Okay. Why? Because we want to make sure the maximum amount of light is going through our sample that we can get an accurate and precise reading. So, how do we do this? Well, remember, you're going to hold on to the cuvette, and you want to make sure that it's clean. Now, I'm going to give you guys clean cuvettes, all right? So, put the cuvette down. We have our solution that we made just a few minutes ago. Pop that open. You're going to take your dropper. You're going to go in. And what you're going to do, you're going to put it in the cuvette. Okay, you're going to put that in the cuvette. Now the question is, how far do we need to fill the cuvette in order to make this happen? Okay, well, you don't have to fill it all the way. 2/3 of the way will do the job nicely. Okay, so about this much. About this much. Now, at the desk, at the station where I'm going to be, I'm also going to have a cuvette, but I'm going to have that with distilled water. The reason for that is it's going to be my blank. We need a reference where we have about 100% transmittance. So, you go in. We're going to open up the slide, and what we will do, we're going to insert the cuvette, the ribs facing you. See how it's facing me? We're going to put it in here like this. And then we're going to close the top. Now, in this case here, because it's a blank, I'm going to go ahead and I'm going to calibrate it. Okay? So you'll see the button, the red thing flashing. It's stopped. It's calibrated. This is good. Okay, goody. No water has spilled. Okay. So what do I do here? On here, you're going to see the little lost symbol, the Dharma symbol that says keep. So I'm going to press that, and I'm going to call that event 1. It really doesn't matter, okay? I'm going to press OK, and I'm going to press my XY, so I have, and this is where we're going, I don't know how well we're going to see this here, but you're going to see you're going to see an event 1. You see transmittance where it says 100.46. It's close enough for what we're going to do. You say, wait, there's more than 100% of the light transmitting. Just work with it. Okay, and then we have absorbance of 0. Okay, well, the absorbance of 0 is telling us that none of the light is being absorbed by our cuvette filled with distilled water. This is totally normal. Okay, great. So now we can go ahead, we can take that out, and we can set that to the side. We're going to take our we're going to take our cuvette with our solution in it. Okay, we're going to put that in. Close it. Now we don't have to calibrate. We don't. It's already calibrated. It's ready to go. Now we're going to hit keep. We're going to call it event 2. Press OK. And in this case here, what's the data that you need to write down? You need to write down your transmittance. How much light was transmitted? 20.63. Okay, and the absorbance is 0.685. All right, that's fine. So this is what we have. So that's our data. We have our percent transmittance. Okay, what's going to be our next thing? We're going to dilute our solution. Now we're done with the colorimeter. We're going to dilute our solution. You're going to take this. Okay, you're going to dump that in the sink, and you can rinse that out with distilled water. Okay, very fast. Okay. And we have that. But now we're going to go ahead and we're going to work with, we're going to move this away, put that off to the side. So then we're going to work with this again. So we're going to dilute it. Okay? And that's going to be the subject of another video because I am running out of time. So we're going to be doing this dilution a few times for this. But that's the basic idea behind our lab. Okay? This is Dylan Attridge signing off.